Hello world, my name is Shithij, this is the coding tree, and today we're talking about classes, part 1. Before we can even begin talking about classes, however, we have to start with object-oriented programming, otherwise known as OOP. Now I know, that sounds like a really big, annoying technical term, but it is important to know because of what it relates to in classes. And don't worry, it really isn't that bad. Over the past few months, how have we been organizing our code? Well, we've been using functions, logic, variables, if statements, conditionals, and loops to organize our code over the past few months. All we're doing now is adding another dimension to that, one that will allow us to write more dynamic and better maintained and manageable code. All we're doing is essentially creating our own objects, thus object-oriented programming. But what exactly is an object? Well, to define objects, it's much more simple to just give an example. Objects can be many things, but let's say for now we want to programmatically represent a person. Let's say I wanted to organize my code to include information about that person and store it in a programmatical way as I would a list. So, how could I possibly do that? The big goal of creating a person object is storing information about that person in a way that will allow me to call it later. So I can access that person's name or phone number or email if it's given and it's stored in my database somewhere. Just somehow I need to be able to access those numbers for when I need to use them in my program. But actually implementing that without object-oriented programming is quite difficult. Without object-oriented programming, it would make sense to just store all of our information in a list, where each specific individual list stores the person's key attributes. So we can say that the first index stores the person's name, the second index stores their age, the third index stores their phone number, etc. However, there are some clear problems with this code. Namely, it just doesn't seem maintainable or manageable. What if I wanted to change that so instead of the person's name being stored in the first index, it was stored in the second or third or fourth? Doing so would be extremely complicated. Additionally, I'm just going based on of convention. If I even, well, in writing my code, forget where the person's first name is stored, well, I just have to manually try it, and finding that error later on in debugging is going to be extremely complicated. As such, it simply doesn't make sense to represent people using lists of attributes. That's when object-oriented programming comes in. The code that we wrote before would frankly make any experienced programmer vomit. We need to write a better way to store that information about a person. There are a lot of things that define a person: their name, their age, their gender, where they were born, etc. If I want to programmatically represent a physical human being, I'm going to need a very large repertoire of data. Let's even say that I only had 10 things that I wanted to store in my database of within each person. Well, even doing so with a list gets increasingly complex, and that's just something I don't want to do. That's why classes are just so vital, and that's why we need to use classes in our code, because they fill that void created when there's no way to represent these objects. They function as object-oriented programming, which is the ultimate goal right now. Think of it like creating your own data types. You can create an integer, you can create a float, you can create a bool, but you didn't make those data types, you're just using them. Now we're going to use the existing data types to create our own. So now we can actually try to create a person. That, however, is not as simple. What we have to do essentially is create a class for a person, and then later on we can use that class as our own data type. But more than just creating a person, classes get so much more useful as they get more complicated. Let's say that I wanted to have a base person class, but I wanted to have an additional class or two that are people, but not all people are these classes. For example, students. I'm a student, you're probably a student, and let's say that I wanted to create a class that has a person and then another class that takes all of the properties from the person class and then adds them to itself. Every student is a person, right? So let's say that I wanted to store the name, age, phone number, address, gender of every student and person, but for only all of the students, I also wanted to store their grade level and student ID. That's why classes are just so useful. Instead of having to write all of that code myself, having to have separate classes for students and persons, I can just have one base class for person and then have the students class inherit all of that information from the person's class. So classes will allow me to represent more dynamic and more data than before. I can also use these per people, and then I can use these students as separate values. So each person is going to be able to be a singular variable because it's a data type that we essentially created, and each student will be able to be their own singular variable because that's also a data type that we created. Only difference between the two is that the students have the additional data types and attributes that we're adding to them because not all students are people. Not all people are students, but all students are people. That's why we need to be able to create the separate data types for each. If I want to represent Joe, who's a teacher, and Bob, who's a student, that's why I need to have those separate classes, yet students can still borrow from the people class. When it comes to actually writing classes, well, we're just about out of time for this video. This is part 1 of classes out of 3, so be sure to tune in next video where we will go over writing our own person class and going over how we can use that in a dynamic program. That's all, folks. I hope you enjoyed and I hope you learned something. If you did, make sure to like, and if you want to continue on your computer science journey, make sure to subscribe. This was part 1 out of a 3-part series, so make sure to tune in for the next video where I'll go over more in depth for classes.